Hey everybody, welcome back. This is Mr. Schultz again, back with your lesson for 216. I'm another one of the 8th grade middle school math teachers, and I'm going to be walking you through this lesson here. So in chapter 2, we're in lesson 216. I'm just using the ebook to show this at first, and then we'll get into some of the student e-tools and whatnot here. So let's take a look at this. So 216, which is greater? Using algebra tiles to compare expressions. Can you always tell whether one algebraic expression is greater than another? In this lesson, you will compare the values of two expressions, practicing the different simplification strategies you have learned so far. So problem number 256, which is greater? Write an algebraic expression for each side of the expression comparison mat given below. Use the legal simplification moves you worked with in lesson 2.1.5, so our last lesson, to determine which expression on the expression comparison mat is greater. So yesterday we talked about Carl, and he was showing us the different legal simplification moves. So I'm going to quick go over those just as a reminder. If you want to try this first one on your own, I'm going to be walking through it. You can jump ahead in the video to when I show the solution, and then we'll go from there. So I'm just going to use the student e-tool right here. So I'm going to click on the link for A. And I've got 3 legal simplification moves that we're going to be talking about here. And it's kind of like 4. But the first one that we talked about from yesterday was if I've got opposites. So in my positive region on the left side, I've got a positive 1 and a negative 1. Well, those are opposites on the same side of the expression mat. So a positive and a negative just makes 0. So those can just be removed. That's a legal simplification move because I'm just making plus 1 minus 1 be nothing because that's what it is. And the same rule applies to the negative side. So again, I've got a negative and a positive. So they're opposites. On the negative side, I can remove them. So that's your first legal simplification move. Your next legal simplification move we talked about was flipping. So basically, if I've got stuff down here in the negative side, so I'm looking at the right side mat, and if I've got a positive 1 in the negative side, I don't really like things in the negative side. It just kind of makes me think a lot more. I'd rather have everything be on the positive side. This is a little bit easier for my brain to handle. So I want to flip this positive 1 from the negative side to the positive side. But I can't just straight up move it up there because if I just move it up there, I've turned this 1 from a negative 1, from a subtracting 1, to an adding 1, which is different. It's not the same thing. So it's not a legal move because I'm changing it. So if I move it up there, I also have to flip it to be a negative 1. And same type of thing here with these other 3. If you're wondering why I keep saying the word flip, I'm going to grab a tile and show you why I keep using the word flip. So this is pretty tiny, so I'm also going to use one of the bigger y-squared ones. But if I've got this positive 1 piece down here, the reason why I'm saying to flip it is because if I flip this piece over, it goes to a negative. Let me show it to you with a larger piece here. So this would be my positive side of y squared. This would be my negative side of y squared. So when I'm talking about flipping something, taking it and I'm just flipping it over that line to make it go negative. So that's why I keep using the word flip. So you've got your 2 moves of if they're opposites on the same side, then you can remove them. You can do your flipping up over that line, and then the third one that I'm going to talk about is this. And I'm going to jump back to kind of reset this so that you can see it. If I've got the same thing, so I've got a positive and so I'm back on the left side. I reset the e-tool here. If I've got a positive and a positive, but they're on different sides. So I've got a positive on the positive side, and I've got a positive on the negative side. I can take those 2 same things and remove them. Same rule applies with the negative. If I've got a negative on the positive side and a negative on the negative side, I can take those 2 things and remove them. And look, I've got the same thing left. I've got a negative 3. And on my other example here, I'm going to switch tabs. I also was left with this negative 3. So both of those moves work for legal simplification. So that's your third move. Your kind of fourth move here is when you're comparing the 2 sides. If I've got the same thing in the same region on both sides, I can remove them. Because this is a -3, this is a -6. So it's like saying if I remove 3 from this side and remove 3 from this side, it's going to end up helping me just kind of simplify it down even more. This is if you're stuck and you're confused and you can't quite see the difference thing, but it's a little bit easier here when you're down to just numbers to see that this side is -3 and this side is -6. But you can go and say, okay, I've got a negative and a negative, and I'm going to grab those two sides, so one from the left and one from the right, and I'm going to remove them. I've got one negative on the left, one negative on the right. I'm going to grab those two and remove them. One negative on the left, one negative on the right. Grab those two and remove them. And so then you'd be left with 0 tiles on the left side and -3 tiles on the right side, which just even more clearly shows how the left side would be greater in this situation. So as far as the expression, if you wrote the expression as -3 is greater than -6, perfectly great with me. If you write it as 0 is greater than -3, also perfectly great with me. Okay, why don't you pause the video and try part B here. See what you come up with on part B, and then I'll walk you through it here in just a second. Okay, so welcome back here to part B. I'm going to use the student E tool once again to show this, and I'm just going to start doing legal moves. You may have done your legal moves in a different order, and that's just fine. So long as you're doing legal moves, we should get the same result. So here, I'm going to take the same thing on opposite sides, and I'm going to remove it. So I'm working on the left side, so I had the same thing, which was a positive and a positive. Now I'm going to do my flip method. So I'm going to flip this positive I'm going to flip the positive one from the negative region into the positive region, and I'm going to do that with the other tiles that are down there as well. And then I'm also going to do this with my X rectangle here. So I'm going to take the negative X rectangle from the negative side and move it to the positive side and change it to be a positive X rectangle. Now let's take a look at the next one. So again, I've got same thing on opposite sides, so I can remove those two. I think I said left side. I meant to say right side. On the right side one, I had a positive in the positive and a positive in the negative, so I took the two same things and removed them. Two same things here again and remove them. And then I'm going to do my flip up method here and turn the positive that was in the negative region to the negative in the positive region, and I'll be left with this stuff. Now, this might be a little bit harder for you to see. Right now, we currently have this. We currently have x minus 2 for our right side, and then we have x minus 6 for our left side. So, right now, the right side is bigger because x is the same value. So this is where removing them from removing the same thing in the same region from the different mats can be useful. Because it might be a little bit harder to see that like that. But if I take the x and I say, well, it's the same thing in both of those two regions and it's both in the positive and remove it, now it just becomes -6 and -2. And so the -2 would be greater than -6. And if you really want to get down there and do that same removal thing with your negative cubes, you can find out that your -4 would clearly be smaller than 0. So any of those expressions there I think is great. If you wanted to do something like this, which was -6 is less than -2, or if you wanted to do -4 is less than 0, all those expressions there I think are super great. Let's take a look at our next question. So I want you to try questions C and D. Try both of them on your own, and then I'm going to show you how I went through and solved them. Okay, so I'm back and I'm ready to solve part C here. I'm going to use the student E tool again, which I already have open. So here, just start taking out the same things. So same thing on both sides of the mat. I'm going to take it out. Same thing. So I'm taking both the positives out of the top and of the positive region and the bottom region. I'm going to take the negatives that are the same in the positive region and the negative region out. I'm going to take the y's that are the same in the positive region and the negative region. I'm going to take those out. And then I'm going to flip this y up because, like I said, I just don't love things being down in the negative side. I'd rather have everything be on the positive side. Let's do the same thing on the right side expression mat now. So I've got a negative and a negative in the two different regions. And so I'm going to grab those two and do them and move them out. If you want to do more than one at the same time, that's also a perfectly great idea. I've got a positive and a positive in the two different regions, so I'm going to remove those out. Now I'm going to use my kind of zero pairs thing. So I've got a positive and a negative, both in the negative region, so I can remove those. And then I'm going to do my flip up method. So you get things out of the negative region. And I'm left with a negative y minus 2 and a negative y minus 3. So to write the expression for this one, I would have a negative y minus 2 and a negative y minus 3 in those two places there. So just to be extra clear, remember if it's the same thing in the same region, then I can remove them. So I'm going to do same thing in the same region from the two sides of the mat. I can remove them, and you can get yourself all the way down to, okay, 0 and minus 1. So that tells you that the negative y minus 2 would be greater than the negative y minus 3. Let's jump to letter D here. So I'm going to jump over to that E tool, and I'm going to do much of the same thing here. So let's see here. I've got on my left side, I've got a negative x and a positive x in the negative side of the region. So I'm going to group those and remove. I'm going to flip up my negative 1 to make it a positive 1. On the right side, I am going to take same thing on the positive and the negative side, which is the x. The positive x is the same on positive region and the negative region, and remove that. And I'm going to flip all this stuff up from the negative side to the positive side, everything that was left over. I'm left with x squared plus 4 and x squared plus 2, 4, 5. So my equation here is going to be x squared. Whoops, that's a crazy squared. I forgot how many I've got there. 4. And I've got x squared plus 2, 4, 5. So kind of seeing that same thing of, okay, well, I could just remove both those x squareds, and then I'd have that the 5 or the right side is going to be greater. But if you want to see that all the way through, I've got an x squared and an x squared on the two mats, both on the positive side, so I can remove it. I can remove a positive and a positive from both mats. I can remove a positive and a positive, and so on and so forth. You've seen this a few different times, so I'm going to do 2 at once now. And I'm left with 0 on the left side and 1 on the right side. So the right side would be greater because 1 is bigger than 0. Okay, let's take a look at the next problem, and this will be the last one. If you want to, take a run at E and F. They're interesting and they're a little bit different. So kind of an interesting extension there. But looking at question 257, build the expression comparison match shown at right with algebra tiles, or explore using the E tool. Simplify the expressions using the legal moves you developed in 2.1.5, and then can you tell which expression is greater? Explain in a few sentences on your paper, and we'll share it as a class. So I want you to take a second on 2-57, and I want you to see what you come up with first. So try this one on your own first, and then pause the video, and I'll come back in and see what you came up with. Okay, so we're back, and I'm going to use the student E tool here. So I've already got that open in a new tab, and I'm just going to go through and simplify. So opposites on the same, so I'm starting with the left side. I've got opposite tiles on the same side of the mat, so I can remove those. I'm going to flip up this positive 1 into the positive region and make it a negative 1. Looking at the right side, I've again got this 0 pairs in the positive region. And then I'm going to flip up all of these here. All of these leftover positives here. And then I've got things that I can simplify here. So I'm going to remove an x and an x from both sides. And then I've got 2 negatives that I can pull from both sides. And I'm left with this. I'm left with 2x and 2, 4, 6 negatives. So if I look at this, I'm left with 2x, and I've got negative 6. So which expression is greater? Some of you might say, well, the x, because rectangles look bigger than the negatives. But what happens if I told you, what if I told you that x is equal to negative 3? or let's choose a different number. Let's make it -4. Well, if x is equal to -4, this side, the left side, would now be equal to -8. And -8 is definitely not bigger than the -6 on the right side. But what if I told you that x is equal to 0? Well, 0 times by 2 is just 0, so I'll be left with 0 on the left side, and 0 is bigger than -6. So when you don't know what the x is, if you're left with stuff you won't always know. But where we're going with this is that eventually we're gonna start to solve for that x and say, can we find out what that x value is? Okay, the last thing that I want to point out here, if you got confused when I was doing the legal simplifying moves, in your math notes, it's got all three of them well laid out here. So removing an equal number of the opposite tiles that are in the same region, this is one of the legal moves. Doing the flip, so moving something from the negative region to the positive by flipping it and changing it from a positive number to a negative number. This is the second note. And then the third thing is removing equal number of identical tiles from different regions. So removing 2 negatives from the positive and 2 negatives from the negative region, and removing both of those. Those are kind of the three. The one that they don't mention here yet is just when you've got two expression mats. And so for example, if I had a second expression mat here, is saying if I've got an x on this side and an x on this side, and they're both positive, and they're, in this case, they would both be negative, I can also remove those. But so far, those are just those three. So that's everything for today. Please reach out if you have any questions to your teacher. They would love to help out. Thanks.